What's up, beautiful people? Another day, another study. Actually, I'm joined today by a really good friend of mine, Bane. Say hi to the people, buddy. No? Okay. Usually he's upstairs with the baby, but he decided to be down here with me today. So joyous occasion. But anyway, what are we talking about today? I find studies like this interesting. Of course, if you've listened to any of my videos or heard me speak, I'm a big proponent of risk mitigation, prevention, screening, accurate interpretation of blood tests, all of that. Well, it's estimated that 620,000 people will die from cancer in the US in 2025. And currently, one of the areas that we really need more help in is cancer screenings. We have screenings available for some types of cancer like colon, lung cancer, breast cancer, prostate, cervical cancer. But other times we often find cancers too late where they've already spread. And then we know survivability goes down dramatically when cancer has spread. So this was a modeling study using relatively new technology called multi-cancer early detection testing. This is utilizing blood testing. Have you seen Grail, the company? They do this. Well, we don't really have a lot of great data in this area, and there's a lot of questions that we still have, like what's the ideal screening frequency? Well, this was a modeling study looking at different screening intervals, 1 year versus 2 years, and adding that to additional standard of care for cancer screening, not using this at its own entity. And their modeling study did estimate a reduction in late stage diagnoses and cancer deaths with annual screening more so than every 2 year screening. The problem with the annual screening is there's more false positives, meaning tests that show that there might be something there, but when we do confirmatory testing, it's not. And this is actually a big concern with this type of testing is the false positives. If it's direct to consumer, who's going to follow up on that? Is it going to lead to more costly testing? Is it going to lead to harm like biopsies that go wrong? Or, there's a whole host of things in this area that we're concerned about. Also in this modeling study, they modeled not a real world scenario, 100% compliance with testing, 100% accuracy with follow-up. We know that's not what's going to happen in the real world. There's also some limitations to cell-free DNA testing, but this is a good way for us to design clinical trials in the future based upon these modeling studies to really look at this in prospective or intervention trials. And I'm really looking forward to more research in this area about ways that we can detect numerous different types of cancer early and non-invasively.